All right, let's review a couple problems that dealing with radian measure for our upcoming quiz. So the first kind of problem, pretty simple, writing angles from degrees to radians and radians to degrees. So if we recall, if we're going degrees to radians, we're going to multiply by pi over 180. And if we're going radians to degrees, we're going to multiply by 180 over pi. So in number one, we have the angle in degrees, namely because you see the degree symbol. So when we're changing it, we'll take 165 degrees times pi over 180. That will cancel my degree units and just leave me in something that is in radians. So if I multiply, I'll get 165 pi over 180. So from there, I just need to simplify my fraction. So I can divide 165 and 180 by 5 for sure. That'll give me 33 pi, because 165 divided by 5 over 36, because 180 divided by 5. Now these both actually divide by 3 again, so I get 11 pi over 12. Now, you can do this lots of ways. You can simplify the fraction in our calculator or anything you want. You can do it in a couple steps. You can do it in one step. If I would have divided these both by 15 in first, then this would have happened, but either way works just fine. Now, the next one, we're trying to write this angle in degrees. So this is a radian measure, negative pi over 10. So we're going to multiply by 180 degrees over pi. Now the nice thing is with a lot of radian measures, this unit of pi will cancel. So we'll get negative 180 over 10, which is simply just negative 18. Or you could just multiply straight across, negative 1 times 180 divided by 10. All those are fine ways to go. So the second kind of problem we talked about were coterminal angles. Now, coterminal angles were angles that added in the same spot, but were different angles. And we said we could always find these by adding and subtracting full turns, which is 360 degrees, or if you're in radians, adding and subtracting 2 pi. Obviously, if you're in degrees, you want to stay in degrees. If you're in radians, you want to stay in radians. So for a degree one, it's really, really simple. We'll just take the angle we're given, and we'll add 360. And then we'll take the angle we're given and we'll subtract 360, making sure that our final answer, one is positive, one is negative. So if I add these, I'll get 495, which is definitely a positive angle. And if I subtract, I'll get negative 225, which is a negative angle. So all I want when it says one positive, one negative, I want one of my answers to be positive and one to be negative. Now for radians, so obviously the other angle here, negative pi over 5, is in radians. I'm going to want to go ahead and make sure that I do my angle in radians. So I'm going to add and subtract 2 pi versus 360. So again, we utilize the calculator a lot for this. You certainly don't have to. Negative pi over 5 plus 2 pi. Negative pi over 5 minus 2 pi. When you're adding fractions again, we just need common denominators. So this is just simply going to be negative pi over 5. And I'll switch this to common denominators of 5. 2 pi is 10 pi over 5. That way I can add and get 9 pi over 5. That's one of my angles. And then my other one simply is going to be negative pi over 5 minus 10 pi over 5 when I convert the 2 pi to fifths. So I'll get negative 11 pi over 5. So those are two angles. If I were to graph these two angles in standard position, they'd be in the same exact position as this original negative pi over 5. Okay, the other things we did in these first couple of sections, we saw some applications of radian measure, mainly the arc length, the sector area, and then linear and angular velocity. So for this one, we're looking for the length of the arc and the area of the sector. Now the big thing for both of these is we want to make sure that our angle is measured in radians. If our angle is measured in radians, these are pretty easy. The arc length, if you recall, is r theta, and the sector area is 1/2 r squared theta, as long as theta is in radians. Now in this first circle, we have this little arc here in this little sector, and the angle's already in radians, so that's great. So the arc length here is simply the radius, which is 17 inches, times the angle, which is pi over 5, and our unit would be in inches. Now, if I want to go ahead and figure out what that is, I can take 17 times pi over 5 and get the decimal approximation. So the arc length would be about 10.7 inches. Now for the sector area, again, already in radians, so that's nice. So 1/2 times our radius squared times our angle, and that is going to be in inches squared because it's an area versus a linear model. So we'll just do 1/2 times 17 squared, and then times our pi over 5. So I'm getting 90.8 square inches. So quite a big area, pretty long sector or arc length, but again, this is 17 inches, so that's a pretty big circle. Not quite as big as this next one, because this next one has a radius of 2.4 yards, so even bigger. Now the problem with this one, the reason this one's not going to be quite as simple, is our angle is 250. That's not in radians. So the first thing I'll do is I'll take this 250 and I'll convert it to radians by multiplying by pi over 180, just like we did above. So this is going to be 250 over 180 pi. Those will certainly cancel, so not much simplifies here. We just get 25 pi over 18. So that is my angle in radians, and that's what I have to use for arc length and for sector area. So for the arc length, we'll simply do r theta. So that's going to be 2.4 yards times this 25 pi over 18. And our answer is going to be, of course, in yards, because the sector length, or the arc length, is always going to be a linear distance. So we'll just do that 2.4 times this angle, and we'll get that arc length. Which is 10.5. So about 10.5 yards. Now for sector area, same thing. As long as your angle's in radians, no problem. 1/2 r squared theta. So this is 1/2 times 2.4 squared times 25 pi over 18. Most of these literally are just going to be plugging numbers in to these formulas that hopefully you are putting on your note card so you remember these. So I put this in the calculator. I'm getting about 12.6 square yards. All right, our last applications are going to be the linear speed and angular speed that we talked about in section 3. So these have formulas that the linear speed, if you recall, linear speed is r theta over t. And then our angular speed is going to be just the angle divided by t. The biggest thing that we had in this one is we wanted to make sure our units are correct. So in this problem, it says the diameter of each tire on a vehicle is 32 inches. If the tires are moving at a rate of 800 revolutions per minute, find the linear speed of the vehicle in miles per hour, So we know this thing has a radius of 16 inches because the diameter is 32 inches. We know it is doing 800 revolutions in 1 minute, so our time is 1 minute. Now our angle is what's going to be big. So we are doing 800 revolutions every minute. And remember, every revolution is 2 pi radians. So when I'm finding the radian measure, I'll do the number of revolutions times 2 pi. So if we look at our units, we're going to be in inches per minute because we have inches for our radius and minutes for our time. So we'll have to do some converting to get it to the correct one. But linear speed is v, so it's going to be r, which is 16, times our angle, which is 1600 pi, divided by 1 minute, and this is in inches. So we're going to have to convert inches to feet, and we're going to have to convert minutes to hours. So the first one's pretty easy because we know there are 12 inches in 1 foot. So those will go ahead and cancel out. So that gives me a factor of 12 on the bottom. Now, if I want to go to miles, a little bigger number. Remember, there are 5,280 feet in every 1 mile. So now I have my unit of miles on the top. So now I just have to convert the minutes to hours, and that's pretty simple. We know there are 60 minutes in every 1 hour. So that will cancel that unit out there. So now I'm left with miles and hours, which is exactly what I want. So if I multiply all this out, and again, I'm just going to put everything on the top. So 16 times 1600 pi times 60 at the end there, all over 12 times 5280. So this is going to turn out to be about 76.2 miles per hour. So not an impossible speed, but pretty fast, pretty fast. This thing's going pretty quick, tires moving pretty quick. So pretty fast linear speed. Okay, finally we're going to do one on angular speed. So the angular speed example says the drum in a washing machine spins at 1200 revolutions per minute. If the radius of the drum is 38 centimeters, find the angular speed of the drum in radians per second. Now, ironically, since angular speed is theta over t, we really don't care what the radius is. It's kind of extra information in this case. But I do know that this makes an angle of 1200 revolutions, so that's 1200 times 2 pi. So that's 2400 pi radians. And the time it does that is in just simply 1 minute. So my angular speed is simply going to be 2400 pi radians in 1 minute. Now, unfortunately, if you look at this problem, it wants our answer in radians per second. So we'll have to change minutes to seconds. So we know 1 minute is the same as 60 seconds. So those units will cancel. So I simply get 2400 pi radians per second divided by 60. So this, you could actually do the math. It's 40 pi radians per second. And of course, we could put that in our calculator and figure out what 40 pi is. So 40 times, about 3.14 is about 125.7 radians per second. So hopefully this helps review these first couple sections we've done this semester. If you obviously have any questions, please let me know.